Welcome. Today we will determine the domain and range of 4 functions. We will sketch the graph of each function to visualize its domain and range. The 4 functions are f of x equals x squared minus 4, f of x equals x squared minus 4, all over x minus 2, f of x equals x cubed minus x squared minus 4x plus 4, all over x minus 1, and f of x equals the square root of x squared minus 4. Recall that the domain is the set of all input values, usually x values, for which the function is defined, and the range is the set of all possible output values, usually y values, that the function can present as the input varies over its domain. Let us begin. The yellow curve shows f of x equals x squared minus 4. This is a polynomial function. Polynomial functions are defined for all real numbers because there are no denominators that could be 0 and no square roots requiring non-negative inputs. Therefore the domain is all real numbers, written as the open interval from negative infinity to positive infinity. On the number line we shade the entire real line with arrows drawing in both directions. For f of x equals x squared minus 4. The term x squared is always greater than or equal to 0 for all real x. Therefore x squared minus 4 is always greater than or equal to negative 4. The minimum value of the function is negative 4, achieved when x equals 0. As x grows in either direction, the function increases without bound. Therefore the range is the closed interval from negative 4 to positive infinity. Range equals the set of y such that y is greater than or equal to negative 4. The blue curve shows f of x equals x squared minus 4, divided by x minus 2. The denominator is x minus 2, which equals 0 when x equals 2. Division by 0 is not allowed, so x equals 2 must be excluded. Now let us factor the numerator. X squared minus 4 is a difference of 2 squares. It factors as x minus 2 times x plus 2. The factor x minus 2 appears in both the numerator and the denominator. We can cancel it, as long as x is not equal to 2. After cancellation, the function simplifies to f of x equals x plus 2, with the condition that x is not equal to 2. This means the graph is a straight line with a hole. That is a removable discontinuity. At the point where x equals 2, the domain is all real numbers except x equals 2. Domain equals the union of the open interval from negative infinity to 2 and the open interval from 2 to positive infinity. For f of x equals x squared minus 4, divided by x minus 2. The simplified form is x plus 2, which is a linear function. A linear function takes every real value except the one corresponding to the excluded point. When x equals 2, the simplified expression x plus 2 would equal 4. But x equals 2 is excluded, so y equals 4 is never achieved. The range is all real numbers except y equals 4. Range equals the union of the open interval from negative infinity to 4 and the open interval from 4 to positive infinity. The green curve shows f of x equals x cubed minus x squared minus 4x plus 4, divided by x minus 1. The denominator is x minus 1, which equals 0 when x equals 1. We attempt to factor the numerator by grouping. Group the first 2 terms and the last 2 terms separately. X cubed minus x squared gives x squared times x minus 1. Minus 4x plus 4 gives 4 times x minus 1. The resulting factors are x minus 1 and x squared minus 4 and cancel with x minus 1 in the denominator. After cancellation, the function simplifies to f of x equals x squared minus 4, with the condition that x is not equal to 1. This means the graph is a parabola with a hole. That is a removable discontinuity at the point where x equals 1. The domain is all real numbers except x equals 1. Domain equals the union of the open interval from negative infinity to 1 and the open interval from 1 to positive infinity. For f of x equals x cubed minus x squared minus 4x plus 4, divided by x minus 1. The numerator factors as x minus 1 times x minus 2 times x plus 2. The factor x minus 1 cancels with the denominator. So the function simplifies to x squared minus 4, with the condition that x is not equal to 1. This means the graph is a parabola with a removable hole at the point where x equals 1. Now we determine the range. The term x squared is always greater than or equal to 0 for all real x. Therefore, x squared minus 4 is always greater than or equal to negative 4. The minimum value negative 4 is achieved when x equals 0. And 0 is in the domain. So it is included when x equals 1. The simplified expression x squared minus 4 would equal negative 3. But x equals 1 is excluded from the domain. So y equals negative 3 is never achieved. Therefore the range is the interval from negative 4 to positive infinity, but with the single value negative 3 removed. Range equals the union of the closed interval from negative 4 to negative 3, and the open interval from negative 3 to positive infinity. The orange curve shows f of x equals the square root of x squared minus 4. The expression inside the square root, x squared minus 4, must be greater than or equal to 0 for the square root to be defined. X squared minus 4 is a difference of two squares. It factors as x minus 2 times x plus 2. This product is greater than or equal to 0 when both factors are non-negative or both are non-positive. Both factors are non-negative when x is at least 2. Both factors are non-positive when x is at most negative 2. Therefore, the function is defined when x is less than or equal to negative 2, or when x is greater than or equal to positive 2. The domain is the union of the closed interval from negative infinity to negative 2 and the closed interval from 2 to positive infinity. Domain equals the set of x such that the absolute value of x is at least 2. For f of x equals the square root of x squared minus 4. The square root function always produces values greater than or equal to 0. At the boundary points, x equals 2 and x equals negative 2. X squared minus 4 equals 0. So f of x equals 0. As x moves away from these boundary points in either direction, the value under the square root increases. So f of x increases without bound. The range is the closed interval from 0 to positive infinity. Range equals the set of y such that y is greater than or equal to 0. Now let us compare all four functions together on the same graph. Observation 1. Domain. f of x equals x squared minus 4 has domain all real numbers. Because it is a polynomial with no restrictions whatsoever. F of x equals x squared minus 4 divided by x minus 2 has domain all reals except x equals 2. Because the original denominator is 0 there. Even though the factor x minus 2 cancels after factoring the numerator. F of x equals x cubed minus x squared minus 4x plus 4 divided by x minus 1 has domain all reals except x equals 1. Because the denominator is 0 there. Note that in this case the factor x minus 1 does cancel from the numerator. So x equals 1 is a removable whole, not a vertical asymptote. F of x equals the square root of x squared minus 4 has domain the set of x such that the absolute value of x is at least 2. Because the expression under the square root must be non-negative. Observation 2. Range. The polynomial f of x equals x squared minus 4 has range from -4 to positive infinity. Because x squared has minimum value 0 at x equals 0, giving a minimum output of -4. The rational function f of x equals x squared minus 4 divided by x minus 2 simplifies to the line x plus 2 with a whole at x equals 2. The missing point corresponds to the output y equals 4. So the range is all real numbers except y equals 4. The rational function f of x equals x cubed minus x squared minus 4x plus 4 divided by x minus 1 simplifies to the parabola x squared minus 4 with a whole at x equals 1. The parabola has minimum output -4 at x equals 0. The missing point at x equals 1 removes the output y equals -3. Therefore the range is the closed interval from -4 to -3. Union the open interval from -3 to positive infinity. The radical function f of x equals the square root of x squared minus 4 has range from 0 to positive infinity. Because square roots are always non-negative and equal 0 at the boundary points x equals 2 and x equals -2. In conclusion, always check for 0 denominators, removable factors, and square root conditions when determining domain and range. Thanks and best wishes to you.